Hi folks. Today I want to talk a bit about math. This is likely the most we'll talk about math at one time during the whole course, and as you'll see, it's not really that much. We want to develop some of the foundational concepts for working through equations. This way, when we see math, we will have some sense for how it works. All of this should be review for you, unwelcomed as it might be for some. I do want to emphasize that this is not a math course or a course that has a heavy mathematical burden. We'll not be doing much math at all, at least not from a pencil and paper point of view. Instead, we'll rely on the computer to do the calculations for us. That said, we do want to have some idea what the computer is doing. Okay. The main idea we want to develop here is that the order of operations matters. That is, when we work through an equation, the order in which we work through the various pieces is important. Luckily, there's a right answer here. BEMDAS is an acronym that describes which parts of the equation ought to be evaluated first. The acronym stands for brackets, exponents, and logs, multiplication, division, addition, and subtraction. I want to work through a few examples so you can see what the basic idea is. Here are three equations that we'll work through. The first one, 2 plus 3 times 4. If we worked left to right, we would add 2 plus 3 first and then multiply the sum by 4. However, that's the wrong way because multiplication comes before addition in the order of operations. So when we evaluate this equation, we multiply 3 by 4 first, which is 12, and then we would add to 12 2, which would equal 14. In the second problem, we have 2 divided by 3 times 4. Technically, the multiplication should happen first, in which case we would multiply 2 times 4, which would give us 8 divided by 3. In the third equation, we have 3 squared plus 4 times 5. First, we evaluate the exponents, 3 squared, which is 9, plus 4 times 5. Next, we evaluate the product, 4 times 5, equals 9 plus 20, equals 29. The next thing I want to talk about is the logarithm. A logarithm is a function that has a base value. Common values here are 10 or 2.718, which is also known as E, or Euler's constant. And it figures out to what power you would have to raise the base to obtain the number. Here are a couple of examples. So, to what number would we have to raise the base, which is 2, to obtain the value 8? And that answer is 3, because 2 to the third power equals 8, and we know that because 2 times 2 equals 4 times 2 equals 8. To what power would we have to raise 4 to get the number 16? The answer here is 2, because 4 squared is 16. 4 times 4 equals 16. A somewhat more difficult one that we probably would want to use a calculator for, to what power would we have to raise 2 to get 10? In this case, the answer is approximately 3.32. Again, this is something that we need the calculator for, but the calculator can easily tell us the answer. So with that, I'll leave you with a couple of problems to do on your own.